Welcome to the world of Storm Motion Control. I'm William Deacon, Chief Technical Advisor for Storm Products, and joining me today is the Pro Tour consultant, Steve Kloempken. Together we'll be talking about the techniques and methods of Storm Motion Control. We'll be getting into some of the physical characteristics of bowlers, some of the actual lane condition types, and how that requires different bowling equipment that we select. We'll match up players with bowling conditions, and in the end, we're going to show our new product, the La Nina, head-to-head against the competition. Thanks for joining us. Well, Steve, the first element of motion control really is to know your bowler. Luckily today we're joined by one of the greatest bowlers in the world, Storm staff member Pete Weber. Welcome to the set, Pete.
Well, thanks, guys. It's a pleasure to be here at the Storm testing facility. Really looking forward to showing the people how the new La Nina strikes.
Okay, Pete, why don't you go ahead and get warmed up, and Steve and I are going to talk a little more about ball speed, rate of revolution, and axis rotation.
You got it.
Steve, in your experience as the Pro Tour consultant, what have you deemed as the most important characteristic in a bowler's game?
I would have to say the number one factor, the number one variable in a player's game is going to be their ball speed. How fast they throw the ball or how slow they throw the ball is going to make a big impression or a big difference on how much the bowling ball is going to hook, so we need to take that factor into consideration.
How would you break down the speeds?
17 miles an hour or less would be considered slower ball speed. Between 17 and 19 miles an hour would be considered medium ball speed, and anything greater than 19 miles an hour would be considered faster ball speed.
Is there a certain formula that you have to calculate to figure someone's ball speed?
Yeah, actually there is. There is a specific formula, and what you want to do is take the number 40.91 and divide that by the amount of time it takes the ball to get down the lane, which would be from the moment of release to the moment of impact on the pins, and that would give you your actual miles per hour.
Great. What can you tell us about how ball speed affects ball reaction?
Well, your player that's going to have the faster ball speed is always going to prefer either a little drier lane condition or would prefer a ball with a more aggressive cover stock. And then a player that's going to have slower ball speed is always looking to get a little bit more length, and they're looking for a ball to get down the lane a little farther.
Excellent. So speed is the first thing you would consider.
Speed is definitely the number one factor in considering a player's ball selection.
After you've rated their speed, where do you move to
What
next?
you want to go to would be a player's rev rate. Generally, it's broken down into a higher rev rate, medium rev rate, or a slower rev rate.
Well, Steve, what would qualify me to be a cranker or a stroker? How many revolutions do I need to be in that category?
Generally, if you would have any number greater than 14 revolutions, I would classify you as a cranker. If you're between 10 and 14 revolutions, that would be a tweener. And then if you have less than 10 revolutions, that would be your classic stroker.
Now, I'm sure there's something more to this. Axis rotation, does that have anything to do with it?
Axis rotation generally does, and there's three different categories when we talk about a player's axis rotation. The three main breakdowns would be a 0-degree axis rotation, which would be all forward roll. This ball hooks very little. It would have a tendency to hook a little early, if anything. Next category would be a 45-degree, which would be a medium amount of side roll, and that is going to provide a little bit of back end. And the 90-degree rotation would be an axis point that's pointed right at your player. Right off his hand is going to be a lot of side roll. It's going to generate a lot of skid and a lot of back end, sometimes a little too much back end.
Steve, it looks like Pete is fully warmed up. What are we going to now classify his bowler type as?
Today we are going to use the CAT system to find his average ball speed and revolutions. We will have to use our naked eye to assess his axis rotation. Let's take a look at his printout. We see that Pete's initial average ball speed is 18.48, which classifies him at the upper end of the medium range. His RPMs average out to 420, which makes him a cranker. A video analysis gave us 18 as his total number of revolutions, and Pete's axis rotation is about 60 degrees.
What do we learn from this information?
Well, William, his ball speed tells us to select a La Nina with the medium to medium shine surface. He is considered a cranker, so for this condition, we will select a low to medium amount of track flare, let's say 2 inches. This can be obtained with a pin either 5 to 5.5 inches from his axis, or 1 1/4 to 1 3/4 from his axis point. And finally, we note that Pete has a lot of axis rotation or side roll. Again, based off this particular condition, which is a medium volume long pattern, we will select a mass bias location in the strong position.
Wow. Just by knowing Pete's ball speed, revolutions, and axis rotation, as well as the lane condition, you selected a ball layout rather quickly. There must be a method to that.
You bet. First, we'll show you some methods to finding a player's axis point, and then we'll move on to motion control. That was a pretty good shot there, Pete. Now, based off of the oil ring we have here on the ball, we're going to take a piece of tape and we're going to place it on the surface of the ball. and we're going to have you go ahead and throw a shot and see if we can get it to spiral.
Okay. But Steve, when you're trying to find the player's axis point, how do you know where to start the tape at?
Well, you have a pretty high track here. You're within an inch from both the fingers and the thumb. And most high track players are going to have an axis measurement of at least 5 inches from the center of their grip. So we're going to try and estimate here. That's about 5 inches. We're going to have you throw it and see if we can't get that baby to spiral.
All right.
Now, Pete, that tape was pretty close, but we noticed it was a little bit off. It wasn't a perfect spiral. It's about 2 inches or so, a wide circle. So what I'm going to do is take the tape and move it a little bit further from your grip center, have you throw another shot again, and we're going to check and see if we can't get that just a little bit closer.
All right, well, how do you know which way to move the tape?
That's really just one of those things you learn from experience. Okay, let's give her another shot. Well, Pete, that looked like that tape was right on. We're going to go ahead and take our ProSec here, and we're going to find the grip center, and then we're going to go ahead and measure across to find your axis measurement. You are 6 inches over and 1/4 inch up. Pete, it is important to know that this axis measurement can actually change depending on the flare potential or differential that the bowling ball has. This is a medium flare ball. Say we were to drill you a higher flare ball, this axis measurement may actually be a little bit closer to the center of your grip. And on the converse as well, if the flare potential on this ball were less, this axis measurement may actually be a little bit further away from your grip center. All right. Next, we're going to have William display another method of obtaining a bowler's axis point.
A second method of finding a bowler's positive axis point is to use a ProSect and a previously rolled bowling ball. The first step will be to trace the initial flare ring, and that is the ring closest to the thumb and fingers. We want to trace that entirely around the ball. This will be what we call the initial track. After we have the initial track marked on the ball, we will take our ProSect and we will dissect this track by finding measurements on the ProSect equal on each side. I have 6 inches on the left side and 6 inches on the right side. I'm going to mark this point on the ball or bisect it at the 0 point. Be sure at this point not to drag the pencil with the quarter scale, but go against the 0. Now I just want to turn the ball 90 degrees. Doesn't matter if I'm exactly 90 degrees, but again I will look for the points that intersect my quarter scale in the same area. Now we have 6 1/4 on this side, 6 1/4 on this side. Again, I will make my slash at the 0. The point where my 2 slashes cross is the negative axis point. And it's a negative axis point because we've had to go to this negative side of the ball to find this point. Now to get to the positive axis point, we go 13 1/2 inches in any direction on the ball. The ProSect has 13 1/2 marked very well. And that brings us to our positive axis point. Once we've determined where the positive axis point is, we must assign a coordinate for that value. We'll measure that from the grip center. So from the grip center, 90 degrees over, and 90 degrees up to the point we've marked, we'll now take these measurements, and this will be the axis coordinate measurements. Here we have a 1/2 inch up and 5 3/4 inches over. So the axis point for this bowling ball would be 5 3/4 inches over and a 1/2 inch up from grip center.
The third method of obtaining a player's axis point is the use of a ball spinner. As in the second method, we will take our grease pencil and trace the player's initial oil track all the way around the bowling ball. We then tilt the ball to try and line this line up so it's basically following itself all the way around the bowling ball. That was pretty close. We'll make a slight adjustment here. And that looks really good. So now we take our grease pencil, place it on top of the bowling ball, and we have now obtained this player's positive axis point.
That gives us three very simple ways of locating the positive axis point for our bowlers. If we do not have access to a previously rolled bowling ball, we must then ask the bowler the questions that need to be asked to try to find out what their axis point is, or make it as close to determination as possible. And when I say ask the bowler, we want to ask them how far the oil is tracking off of their thumb and off of their fingers. Generally, most bowlers will be able to give you this information within a half of an inch, and from that information we can classify whether they're a high track, medium track, or low track bowler. So if all else fails, if we have no previously rolled equipment to find an axis point off of, we have to make sure to quiz the bowler and try to get as much information out of them as possible. Good luck. Well, Steve, now that we've characterized the first element of motion control being the bowler, we need to talk about lane conditioning. And first, before we can talk about that, we probably need to talk about the surface of the lanes. When you show up at a tournament, I'm sure the first thing you look to see is whether you're bowling on wood or synthetic.
That's absolutely right. The first thing and one of the most important things in analyzing your lane condition is to determine what type of surface you're bowling on. A synthetic lane is going to have the characteristic of providing more length, smoother normally, and the wood condition generally is going to break down earlier and is going to have a tendency to hook a little bit earlier.
Great. Well, once you know what type of surface you're going to bowl on, what's the first thing you're going to analyze?
Generally, we look at the volume of oil, which would be the total amount of oil applied to the lane itself. And we characterize that in three different ways. There's heavy, medium, or light. The light being a light amount of oil, which would be a drier lane condition, and then the heavy being a very slicker, oilier condition.
And after the volume, what are you looking for?
After the volume, then we want to determine what length or how far down the lane the oil is applied. Generally, the cutoff distance between whether determining an oil pattern is either short or long is about 36 feet or so.
That's great. I imagine you see a wide variety of conditions out on the Pro Tour.
Yeah, we sure do. We see conditions that range from the extremely oily to the extreme dry, and a lot of times that can even happen within one day. And that's really one of the most difficult and most challenging parts of our sport today, is analyzing the lane condition.
After we've characterized the type of conditions we'll be bowling on, we need to select the desired amount of length. What would you suggest for dry to light oiled lanes?
For a lightly oiled lane or light volume of oil, we'd want to select a ball that has a higher RG. That one's going to produce a more length, the RG standing for radius of gyration. And for a heavy oil condition, we'd want to select a ball that has a lower RG. This type of core construction is going to produce earlier roll.
Great, so what you're actually saying is that RG is a measurement of length potential, and that higher RG equals higher length potential and lower RG equals lower length potential?
That's correct.
Once the amount of length has been determined, we need to select the amount of overall hook that is required. Again, what do you suggest for light or short oil conditions?
For a short oil condition, we want to select a ball that has a lower differential or a lower amount of track flare. And then for a condition that's longer, we'd want to select a ball that has a higher differential, is going to produce higher track flare.
So again, you're saying that differential is a measurement of hook potential, and higher differential equals higher hook potential, lower differential equals lower hook potential.
Absolutely right.
Excellent. Well, let's move on to the next stage. Well, now that we've gathered all the information we can about our bowler, we've characterized and analyzed the lane condition, and we've tried to gain a general understanding of how radius of gyration and differential match up to different lane conditions, we can go ahead and select a specific piece of equipment for our player. Today we're going to select the newest creation from Storm Products, the La Nina. The La Nina features an all-new cover stock design called Prothane with TDR particles added to it to add high friction. This ball will work best on the heavy to medium oil conditions, and it maximizes control and hooking power. The La Nina features a 2.518 radius of gyration with a 0.045 differential. This will produce a medium flare pattern on the ball. Excellent control ball for heavy to medium oil. Let's go ahead and implement some of the Storm techniques of motion control on these balls for Pete Weber. Steve, you and I have been using the same methods for laying out balls ever since we worked together at the Showboat many years ago. And it really boils down to the pin position, the mass bias placement, and the weight holes, doesn't it?
Absolutely, William. Those are definitely the three important factors we want to consider when laying out this bowling ball. The most important factor is going to be the position of the major pin. The second factor is going to be the position of the mass bias. which is a fine-tuning factor for back-end reaction. And then the third factor we want to consider is whether or not we're going to use a weight hole.
Great. Well, let's get right to it. What do you think about the pin position for Pete Weber's La Nina on this medium volume, long distance condition we have down here?
Well, the pin position I think we should use on this one would be a 5.5-inch pin from his axis point. Pete has a lot of axis rotation, so he likes to keep the flare down a little bit. And we're also looking to promote pretty good length through the front since there's only a medium volume of oil, not real heavy.
Okay, great. 5.5 from his axis point, and we know his axis point is 6 inches straight over from some earlier testing. So let's get to laying that ball out. Well, we know Pete's axis point is 6 inches straight over, and we want to give him a layout with the pin 5.5 inches from his axis point. I'm going to start my prosect with the 0 on the major control pin, and I'm going to put the grease pencil down here at 5.5 inches. I'll swing an arc. Now I know that along this arc, any point I select on the arc will be 5.5 inches from this pin. Well, Steve, what are we going to do about the mass bias?
Well, actually, William, what I'd like to do is set up 3 separate La Ninas, each having the pin distance 5.5 inches from his axis point, and 3 different mass bias locations to really see what type of different ball reaction we're going to get on the lanes.
Great, let's do that. We'll do this first ball with the mass bias halfway between his track and his axis midplane. This will produce a strong mass bias placement and the sharpest back end reaction overall. In order to get that strong mass bias placement, I want to stack the MC squared pin below the major control pin. So to get his grip center, I'll go 6 inches straight over, which is Pete's axis coordinates. There we have his grip center. 5.5-inch pin, strong mass bias placement. I'm going to drill the second ball with the pin 5.5 inches from the axis point. So I'll swing my arc 5.5 inches. And I want the mass bias to result in the track. So I need that to be to the left of grip center. I'll rotate that to the left. Now I'll go back to my arc and select a point that ensures the mass bias is to the left of the track. 6 inches over, which is Pete Weber's axis coordinate. And there we have his grip center. The pin will be 5.5 inches from his axis point. The mass bias will be in his initial track. For the third ball, I'm again going to place the pin 5.5 inches from the axis point. I'll draw my arc 5.5 inches from the pin. And now to get the MC squared, or the mass bias, near the axis midplane, I need to rotate this to the right, or out near where the axis would be. At that point, I go and select a point on the arc I've drawn, which will represent the axis point. I'll go 6 inches straight over Pete Weber's axis coordinate. Here I have the grip center. The pin will be 5.5 inches from the axis point, and the mass bias is near the midplane. Well, Steve, I've laid the balls out like you've requested. What do you expect to see out of these different mass bias placements?
Well, the first ball that you laid out, William, was a mass bias in the strong location, and that type of layout is going to produce the strongest reaction on the back end. Next, the layout used was the track location, and the track mass bias is going to produce more length and still be a controllable arc on the back end. And then the third ball we used was the mid-plane layout, and that type of layout is going to produce the earliest roll with a very controllable arc on the back end as well. First, Pete will throw his La Nina with the track mass bias placement. He stood 22 on the approach and is looking 16 at the arrows. Note the good length through the heads and smooth arc on the back end. Now Pete has moved his feet to 26 on the approach and his eyes to 19 to throw the La Nina with the mass bias placement in the strong area. Notice the good length with a very aggressive and sharp move on the back end. And finally, Pete jumps left again to 30 with his feet and 21 with his eyes to throw his La Nina with the mid-plane mass bias placement. Here we see this layout producing the earliest roll with a very controllable back end.
So there you have it. We demonstrated 3 La Niñas with the same pin distances to axis and 3 different mass bias placements. Note the wide range of ball motions produced with the simple movement of the MC² pin. Remember, it's the motion control core that makes this all possible.
Jesus, man, that ball just hooks way too early. Steve, this ball's hooking way too early. Can you help me out here?
Yeah, absolutely. This is the box finish on it right now, so what we can do is go back and put some Storm Extras #1 on it. That'll give you a little bit more length, and we can even go a little bit shinier as well. So we can go #2, #3, or even extra shine.
Okay, very good.
Here we go, Pete. We got this all cleaned up with the Extras #1. Why don't you go ahead and give her a shot and see if that helps out.
Okay. Yeah, baby, that's right. Steve, I really like the surface of the ball, but it's just not hooking enough. What can we do about it?
Let's go ahead and put a weight hole in here. That's going to bring the reaction up to us just a little bit quicker. Let's go ahead and do that.
All right.
The use of any type of weight hole at all is going to bring your reaction or your break point closer to you. So a ball with a weight hole will react sooner or earlier than a ball without a weight hole. If we put the weight hole on the axis point, that is going to decrease the track flare. It's going to keep the ball a little bit cleaner through the front part of the lane. If we place the weight hole off of the axis point, that is going to promote more track flare and is noticeably going to bring our reaction up to us. Well, Pete, here we go. We placed the extra hole on your positive axis point. This is going to make the ball a little bit stronger overall, but it's still going to be clean through the head. So this is going to produce a stronger reaction down the lane.
Let's discuss motion control by adjusting ball surface. Surface is by far the #1 factor in motion control. First, let's discuss the 2 components of ball sanding, direction and grit coarseness. Direction. There are 3 sanding patterns which create different types of ball motion. The first pattern would be sanding parallel with the bowler's release track. Sanding parallel with the release track on a low flare ball will promote length to the front portion of the lane and an even arc on the back end. Sanding parallel with the bowler's release track on a high flare ball will promote length through the front portion of the lane with an aggressive reaction on the back end. This directional pattern becomes more beneficial as the head portion of the lane becomes more dry and the back end portion of the lane becomes more oily. When used on a low flare potential ball, sanding against the perpendicular ball track will promote a more aggressive reaction in the front end of the lane and a more aggressive reaction on the back end. However, if used with a high flare potential ball, this pattern will promote a more aggressive reaction in the front end of the lane and a more even reaction on the back end. This second pattern is most beneficial when the lane conditions are heavy oil in the heads and pine and dry back ends. The final sanding pattern promotes the greatest amount of overall hook. This pattern is achieved by placing the flare point straight up in the ball spinner and sanding perpendicular to the ball track around the entire circumference of the ball. Once again, this is the most aggressive pattern that can be used regardless of the flare potential of the ball. Certainly, the greater the flare potential, the more hook you will see. Well, that covers our directional patterns. Now let's talk about grit coarseness. Sandpaper can range from 80 grit all the way up to 1500 grit and above. Consider 600 grit a benchmark medium surface. Smoothing the surface creates greater length with stronger back-end reaction. Roughing the surface creates earlier roll with less back-end reaction. Next, let's talk about Storm Extra's professional ball maintenance system. The Extra system features steps 1, 2, and 3 finishing compounds, which range from 220 to 2500 grit. Storm Extra's step #1 takes the ball from 220 to 800 grit. Storm Extra step number 2 will take the ball from 320 to 1500 grit. Just apply a small amount on your towel, rub it on the ball, and spin for 30 to 90 seconds depending on how much shine you want. Finally, step number 3 will bring the surface from 1500 to 2500 grit. Notice that by using just steps 1, 2, and 3 on this box surface La Nina, we've changed the condition of the surface from dull to shiny without the use of any sandpaper. For drier lane conditions, we have Storm Extra Shine and Diamond Gloss. Storm's Extra Shine will bring the ball surface to a smooth 3500 grit. Storm Extra's Diamond Gloss will provide the maximum shine you can put on a bowling ball. To remove dirt and oil from your bowling ball, use Storm's React-A-Clean for reactive urethane bowling balls and U-Clean U-Score for conventional urethane bowling balls.
Now we're going to demonstrate the versatility of the Storm line. Pete, are you ready to go?
Let's do it.
All right. Pete will be throwing a ball from each of Storm's high-performance lines. Each of these balls are drilled identically with a 5.5-inch pin in strong mass bias placement and surfaced identically with a gray Scotch-Brite pad. The lane condition is a medium volume of oil, dressed 40 feet, so we have a medium long condition. Here we have Pete throwing Storm's latest innovation, the La Nina. The La Nina features Storm's new Prothane cover stock, which utilizes AccuTread reactive urethane with TDR particles. Matched up with the new Prothane cover stock is the latest motion control core, which features a medium RG of 2.518, medium differential of 0.046, and a medium mass bias differential of 0.006. The La Nina is designed for heavy to medium oil conditions and is the premier ball of the Master line. Now we have Pete throwing the Firepower. The Firepower, with its medium RG, medium differential, and solid cover stock, is a fantastic ball for medium oil conditions. This ball, along with all balls in the Power line, produce maximum versatility. Here we have Pete throwing the cornerstone of the Flash line, the Meteor Flash. This is an excellent example of the Flash line's length, control, and hitting power. We now see Pete throwing a Hot Shot, the most aggressive ball in the Hot line. Again, another example of the incredible diversity displayed by Storm high-performance bowling balls. For extremely dry lane conditions, Storm has the Flame line, which features conventional urethane cover stock. As you can see, the Flame line delivers Storm striking power. Pete maintains his high spare shooting percentage with a 90 hardness polyester spare Storm. That was a great look at the wide range of motion available with Storm bowling balls. This also was a great demonstration of how different core designs and cover stocks produce different types of ball motion. So Pete, tell us about the versatility of the Storm line.
Well, you know, as many lane conditions as I've encountered out on the PBA Tour, Storm has always had a ball for the condition that I had to bowl on.
And now the competition. For the ultimate test, we drilled 4 of the leading competitors' balls for Pete to demonstrate. This gives us a head-to-head comparison of the La Nina versus each of the competitors. All balls we drilled identically to the La Nina and left with a factory box surface. Take a look for yourself and see the different angles Pete has to play with each of the competitors' balls. For our next test versus the competition, we applied the La Nina's factory surface to each of the competitors. After lining up with the La Nina, Pete threw each of their balls in the exact same spot on the length. Again, take a look for yourself at the results.
And there you have the world of storm motion control.
Well, thanks a lot, Steve, and thank you all for joining us. Hopefully you've gained some incredible knowledge. Now go ahead and put it to use and keep on storming.